Hello, this time we'll be looking at Kirchhoff's voltage law and loop analysis. So I'll be using the same circuit, but I'll draw it back over here just so it's a bit clearer. R1, R3, R2, V2, and V1. So this time we're looking at the loops these branches make. That one and that one. Drawing arrows there. And Kirchhoff's voltage law says all voltages around a loop sum to 0. This is Vn, just as it was before, voltage up to here, and I can draw the currents on again. I2, I3 and I1. Now, the voltage across here, something we've got to be paying attention to. I'm drawing it pointing that way because this arrow is going that way. Those are going in the same direction, VR2, and this voltage going across that way, again, same direction as the arrow, VR1. And that's already called Vn, just there, so we don't need to name that one. So let's write out the equations that sum to 0 of these loops. Let's pick one to start with. So for this one, let's start with Vn. These are going in the same direction, so it's positive. Plus VR2, also positive because it's going in the same direction, 2. Whereas this voltage, which goes that way, of course, looking at the battery symbol, cell, it's going against it, so that must be negative. V2 equals 0. And looking at this loop, that's going in the same direction, so V1 positive, VR1 is positive, and Vn is going in the opposite direction, so that must be negative, minus Vn equals 0. The next step is to look at these voltages. What makes these voltages? Well, a current times a resistance by Ohm's law. We've already got currents written on here. So I1 goes through R2. However, this is pointing this way, and this voltage is pointing this way, which means one of these has got to be negative when we're writing it down, because when a current flows into a resistor, it sets up a voltage across it in that direction, not when it flows out. So we've got to add a minus in here somewhere. So I1 equals minus, VR1, R1 equals minus I1 times R1. And let's look at R3. So I3 is coming out. Again, it's the wrong way around. We'll need a minus. Vn equals minus I3 times R3. And here, VR2 equals, this way, this time it's pointing in the right direction, they're opposing each other, equals I2 R2. And the only other equation we need here, strangely, is this one here, I1 plus I2 plus I3 equals 0. Now you might think just because this is Kirchhoff loop analysis and we're mostly using Kirchhoff's voltage law, we also need Kirchhoff's current law, and we actually had that in this one. Although we were using nodal analysis and Kirchhoff's current law mostly, we made some implicit assumptions about how the current sum to 0 here. When I said, when we formed these equations here, we said that if one voltage up here and one voltage here, the voltage drop across those two must be Vn, across R2 must be Vn minus V2. that's also saying that the voltages in this sum to 0 when you're going around that loop. So we kind of already assumed Kirchhoff's voltage law when we're doing the nodal analysis. This is just doing it more formally, and we're getting different equations. They'll end up the same in the end, hopefully. Something's gone wrong. Now, so I2, I1 plus I2 plus I3 equals 0. So all of these can now be combined together to get the same equation as this. General space there. Let's start again up here. So we have voltages and resistances over here. So if we want the same thing over there, which is what we want if we want to find Vn and not a current first, we want to leave these voltages here. But we don't want the currents. I think this way you tend to get the currents first. But yeah, we can rearrange these, put those in that equation, and then get a third simultaneous equation to solve. Let's do that here. Therefore, VR1 equals I1, equals minus VR1 over R1. Let's just subscript R1. I2 equals minus, that's not I2, is it? I2 is positive. R2 over R2, and I3 equals minus Vn over R3. Now we put these into this equation, we get minus R1 VR1 over R1 plus VR2 over R2 minus Vn over R3 equals 0. So now we have these two equations and this equation, and between them we can solve for Vn, because this isn't known, this isn't known, this isn't known, these two are known. So we've got three unknowns here: Vn, VR1, VR2, and we've got three equations which we can solve simultaneously. I'm not going to do that here, it's just maths, and it's a lot easier with numbers in there because they multiply out. Anyway, I hope you've enjoyed watching and learned something, and thank you for watching.